Right, good morning, everybody. I'll make a start. I see there's still a few people entering. I've got the pleasure to introduce Eamon, who's a fellow BMC software colleague. I think he's probably been in the industry longer than I've been alive. So yeah, really looking forward to this session. And remember, it's session 1AL for feedback at the end. Over to you, Eamon.
Thanks a lot, Harvey. Hello, everybody. Good to see you all, or virtually see you all. Hope everything is lovely and fine wherever you are in the world. As Harvey said, my name is Eamon McGrath. I am from BMC Services, and this is session 1AL. So ACF2 versus RACF. What this presentation isn't going to give you, unfortunately, it's not going to be a tool to assist in converting between the two ESMs. That is a very complicated and potentially dangerous job that requires specialist knowledge and tools. So if you do need to convert between ACF2 or RACF, either way, you would need to seek external advice from experts, CA and IBM being the primary two. It isn't a model for choosing between either ESM. What ESM you require at your shop is really personally down to yourselves. There are a lot of factors involved, and to be honest, what the ESM does is probably fairly low down because both ESMs do pretty much the same thing. They just do it slightly differently. And unfortunately, it isn't going to be aimed at anything higher than beginner. It's very much an intro session, so hopefully I'm not going to blind you with too much science today. If you want to learn how to install security on SDSF, you probably need to go to a different presentation. If you want to manage your started tasks, again, you probably won't find that here. But if you want to just know an intro to both service security managers, here is hopefully the place to be. And following on, for those of you in the UK who have possibly been watching our government's COVID-19 updates, it isn't going to be an exercise in death by PowerPoint. I've actually taken every animation and whatever off this slide following watching the government's crazy PowerPoint presentations. So it is just a flat thing. I'm sorry to say, if you like whooshing, scrolling text, then I apologize. What it is hoping to achieve, though, is to review the basic concepts of mainframe security very briefly, and to hopefully increase your knowledge of either of the mainframe security managers, and hopefully be a bit entertaining and fun. But I put a caveat in here that I will probably stretch the definition of both of those words to their finite limit. It's quite a dry subject, to be honest, so trying to make it entertaining and fun over a Zoom call is going to be hard. So a little bit about me, RACF and ACF2 security consultant. Been doing it for 20 years now. 10 of those years been proudly associated with RSM partners, which are now BMC Mainframe Services. Mostly on RACF, it has to be said, but a fair bit of ACF2 as well along the way. When I'm not doing my security engineering job, I can usually either be found at one of these two places, either a rock gig or a pub. That rock gig is the last gig I attended in March of this year. And anyone who knows me personally knows that that is a phenomenally long time between concerts. It's been quite a hard year concert-wise, certainly for myself. The pub is the Fat Cat in Norwich. It's one of two pubs that has won CAMRA's Pub of the Year, National Pub of the Year twice. The other pub, I believe, is in Sheffield. If you're in Norfolk and you're heading up to Norwich, then the Fat Cat is a decent place to get a beer once we come out of lockdown, obviously. And these days, generally, I look a bit like this because we all have to do our bit to help out. So, 2 external security managers, 1 underlying operating system. They are the same, but they do things very differently, and it's not a competition. An external security manager basically sits on top of ZOS and takes the pressure off of ZOS to handle access requests. Long time ago, even before I was even thinking about jobs in IT, ZOS, if you wanted to access ZOS, you went to your systems programmer and said, I need access to the system. And they'll say, off you go. And you just went on the mainframe, did your thing. And if there was someone else's data there and there wasn't enough space, you probably just deleted it. As the usage of the mainframe became greater, number of users became larger, it was decided that some sort of security and management was involved or was needed. So they basically wanted to just allow valid users onto the system and only allow them the data they required. As you can see by the very simplistic graphic, lots of users there asking the ESM if they can have access. The ESM validates that access or denies it, depending on the return it gets, and allows access through to ZOS if required. ZOS is then free to do what it does best, which is calculate transactions. So if you're a financial corporation, then you are probably doing credit card transactions or ATM transactions. You want your ZOS system to do that. It doesn't want to be bothered with Joe Bloggs saying, hello, can I do this? So a very, very brief history of RACF and ACF2. RACF, as some of you may know, stands for Resource Access Control Facility. It was released in 1976 by IBM and has been around and supported and enhanced constantly since then. It has the largest market share. That's really the briefest history of RACF you'll ever hear. ACF2, Access Control Facility 2, developed and released in 1978 by SKK, which is Schrager, Clemens and Kruger, for all you pub quizzes out there. Marketed by Cambridge, who were eventually bought out by CA in 1987. And they have the second largest market share. CA also have a third ESM called Top Secret Services, but we're not mentioning that because it's top secret and I know very little about it. So again, I did say it was a brief history. If you want a more in-depth one, Google is probably your best friend, or talk to your friendly neighborhood system programmers who have probably been around a long time and can give you much more detail of the history of RACF and ACF2. So firstly, we'll just have a quick look at what's the same in the two ESMs. Both of you use SAF, the System Authorization Facility. Both have security databases. They're not X.500, but they are highly efficient legacy systems that are accessible from X.500 via LDAP. Now, I read that verbatim from something I found on the internet because I know all the words that I've just said, but I don't understand most of them. If you need to know more about X.500 datasets and the RACF and ACF2 datasets or databases in general, again, your system programmer would be able to help you. Both write system management facility records, SMF records, for auditing and reporting, and both protect the data as defined. This one seems a bit obvious. They have rules or profiles that protect the data on the system. They wouldn't be very good ESMs if they didn't do that. So now, again, a very loose definition of the word fun. What is different? One of the problems people have with a system or a security manager they don't know, be it RACF or ACF2, is it's different. Well, it's not necessarily different, it just is named different or worded differently. But the first major difference is, out of the box, ACF2 denies access unless there is a rule to grant access, whilst RACF will generally grant access unless a profile exists to restrict it. And there is an asterisk there, as you'll see. It's the only one on the presentation, but take it as read that pretty much any other slide could have an asterisk on, which means that's generally the case, but there are exceptions to disprove that rule. Let's have a quick look at the ACF2 and RACF databases. RACF has one primary and one backup database. These contain everything, but they can be split into several data sets to reduce contention storage issues. If you don't have a large enough contiguous space on your system, you can break up your RACF database into several smaller data sets. And the RACF database is synchronously updated between the primary and the backup. So basically that means it's, well, as soon as you update something in your primary database, almost immediately it will appear in your backup one. ACF2 has 3 primary databases and 3 alternative ones. The logon ID database, as it suggests, contains all the logon IDs and details around them. The rules contains all dataset rule sets, and the info storage database contains the rest of the ACF2 needs to function. The ACF2 databases are not synchronously updated. You have to manually set up automation. I know that sounds a bit weird, but a batch job needs to be set up, or an ACF2 settings need to be configured to update and synchronize your 3 databases. You can have other backups and unloads on your system. Depending on what you're doing, you may need to take an offline backup. I would suggest, with my security hat on, that any copies of RACF databases or ACF2 databases are secured as well as your primaries. Just because a database is a couple of months old doesn't make it less interesting to nefarious characters who might wish to bring down your systems. Starter tasks and startup. The RACF starter task does not need to operate for RACF to run normally. There are other things that are definitely needed for it to run normally, but the RACF starter task is not one of them. And RACF is part of the operating system's SMP/E for update and upgrading and maintenance, so it makes it very smooth. And the default user ID IBM user must be present. If it is deleted, it is then recreated at IPL, which is the next restart, with enhanced privileges. It will be given as a bare minimum, I believe, operations and special, which we will mention later on. The ACF2 starter task must be active for ACF to run normally. If it isn't, a right to operator request will be produced for every security call, which kind of defeats the object of being a security manager, because you're bugging someone every time someone asks a question, and you will get very irate operators who will be the people being bugged every time it asks a question. It needs to be installed and set into the ZOS SMP environment, so it's not automatic. And ACF user, unlike IBM user, doesn't need to be present and can be deleted, and is recommended is deleted once the system is set up and a secure alternative is created. Just a quick note regarding IBM user for any ACF2 people on here who may be touching RACF. IBM user is recommended that it's stripped back to basically having no access, left in a state that can't be logged on, and just left dormant. So every time the system is IPL'd, it just sits, the system basically goes, oh, IBM users there, I'll carry on, and it can't do anything. So a quick comparison table just on some naming standards. RACF has user IDs, ACF2 has logon IDs, RACF has dataset and general resource profiles, and ACF2 has dataset and general resource rules. Basically, they all do the same thing, but as may be repeated later in the session, they do it very differently. Modes, the default state when you first install ACF2 or RACF. RACF comes defaulted to no protect all, which specifies that RACF doesn't check for protection when processing a request to create or access a data set. So once you freshly install RACF, you can log on and do what you like, and your system programmers and system architects will start to create rules to protect your system. Once they are happy that that's in a state of near perfection, shall we say, they can switch the mode to protect all, which means the system will automatically check and reject any request for access to a data set that is not RACF protected. There are two suboperands for protect all. One is warning, one is failure. If warning is set, it will not fail the request, but it will issue a warning. And if failures are set, it will fail any request to create or access a data set. And if there is an access a data set that is not RACF protected, sorry, and if a data set is RACF protected, normal RACF rules will apply. ACF2 has a bit of a more of a granular approach to modes. Quiet is similar to no protect all, and it only has system entry validation. If you have an ID, you can log on. Log, as its name suggests, has access rule validation, but it logs. It does not prevent access. So it will say, you logged it, you access this, this is the access level you did. Warn is the same as log, but a warning message is issued to the user. Rule I will come back to. Abort is when ACF2 is in full mode and will reject any authorized access and issue a violation message to the syslog. Now, rule is a kind of an odd one in that rule will look for the mode value in the rule that you are trying to access. And if that rule is set to abort, for example, it will do ACF2 checks. If the rule that you are trying to access is set to quiet, for example, it will not do any checks whatsoever. So it's kind of there when you're nearly ready to turn on abort, but not quite sure. But you know you've got some systems sensitive data sets that are ready to be ACF2 controlled, that you can set them to be ACF2 controlled, but other data sets that you are still trying to protect properly, you want people still to have access, but you want to know what they're doing. So you'd probably set it to warn, and then they would get a message and a log would be cut. Most systems that you will log on to, in fact, I would say pretty much every system you will log on to will probably be set to protect all failures and abort. If it isn't, I would question that with one of your system programmers. Global settings. RACF and ACF2 both have these for setting the global security options. RACFs are called set our ops, which stands for Set RACF Options. To update these, you will need RACF System Special for the main, and you will need RACF System Auditor to update the auditing settings. There is a privilege called RO Audit, which allows System Special users to read the audit settings but not update them, because if you have System Special only, you will not see the audit settings if you list the setter ops. ACF2 has its GSO settings, which are the global system option records. You need unscoped security and a refresh privilege to be able to update these sessions. We will go into these security privileges a little bit later on. Data sets on RACF and ACF2, excuse me. RACF data sets profiles can be 44 characters in length. This includes qualifier separators. RACF, you can have as many qualifiers that will fit into 44 characters, but the first qualifier must be an existing user or a group, and no qualifier can start with a number. Access can be via a user ID or a group, or a universal access such as UAC or the ID star. If you're in a fully sort of secure environment, I would hope you haven't got UAC or ID star on many, if any, data sets. Single RACF profile protects a data set. I'll enhance on that in one moment. ACF2 has an 8-character key. It has a 4K limit out of the box. However, there is a global setting that you can add called rule long, which will extend that to 32K. Next keys allow for chaining of rules that reach 4K to exceed that without setting rule long. Once you've set rule long, you cannot go back. I don't know many shops that I've worked on that have rule long set. Most of them have an inordinate number of next keys. ACF2 will read through all the rules to check if one grants or denies access to the requesting user. And ACF2 rules must be decompiled to update and recompiled to take effect, unlike RACF, where they are dynamic. Now, the single RACF profile and reads to all rules part. In RACF, if you have a profile called sys1.star and a profile called sys1.palmlib, and you wish to protect your sys1.palmlib dataset, the sys1.palmlib rule is the only rule that will protect that. If you don't have access to that, but you have access to sys1.star, you will not get access. In ACF2, if you have those rules and you wish to protect the sys1.palmlib dataset and you are in sys1.palmlib with alloc access, you will have alloc access. If you are in sys1.star with read access, you will get read access. So it will read through all rules that could potentially protect the dataset and see if you've got access in one of them. If you have, you are granted the access, assuming you're not asking for higher than the access that you request. RACF access to data sets and to general resources, excuse me, is compounding, which means that higher access inherits all previous levels of access, whereas ACF2 access is individual. So if you are given read, that is all you are given. If you are given alloc for allocate, that is all you are given. You need to be given each access level individually. Another quick comparison table just for access levels. So none is the equivalent of deny on ACF2. Read and read are the equivalent of each other. Update is the equivalent of write. I will skip control for a minute. Alter is the equivalent of allocate, and execute is the equivalent of execute. Execute only applies to executable code and not data files. You will very rarely see execute on an access list on either ACF2, on RACF. You will see it quite a lot on ACF2, but for reasons will be explained in a moment. Control access is the equivalent of update for VSAM datasets. So if you see control on a non-VSAM file, it will just grant update. It's not widely used. I mean, the main ones on RACF are none, read, update, and alter, but control does appear far more than execute does. General resource rules. The length for a RACF profile is determined in the CDT when the class is defined, assuming you're using a dynamic CDT. It can be 1 to 246 characters, including qualifier separators, although it's rare to have qualifier separators in a general resource rule. And again, access can be via the user ID, group, or universal, and a single RACF profile protects a resource the same as data sets. ACF2 has a 40-character max key unqualified, which means A, B, C, D would be an unqualified key, and a 256-character max key if qualified. So abc.def.g would be a qualified rule key. I've never seen, as far as I'm aware, a qualified rule key. So it's generally just the 40-character unqualified. Again, much like data sets, ACF2 has a 4K limit with next keys allowing to chain rules. And it reads through all the rules to check if one grants or denies access, and it must be decompiled and compiled to update. RACF users, ACF2 users. User ID on RACF is a max length of 8 characters. I think it's changed recently in the latest version of ZOS, but it used to be, if you wish to use TSO, you had to have a max length of 7 because an 8th character was added. But I don't know if that is still a valid thing. I would need to check that. And it must be connected to at least one group, which is called the default group. And a quick example there is a user ID called IBM user, connected to the group sys1, and its owner is IBM user. ACF2, the logon ID again must have a max length of 8 characters, and it must have a valid UID string assigned. This is 24 characters in length or maximum length and must contain the logon ID. And the UID string allows for ACF2 to group users into areas because ACF2 doesn't have a grouping system like RACF. And there's an old example of a logon ID that I used to have, which is TSG EMC, which is made up of a UID string, which is TSG, and then ITSU, and then SEC, and then the logon ID. Now those characters before my logon ID, SEC was my area, which was security. TSG was the department, and I don't know what ITSU was, but it was another value. So the logon UID string is made up of fixed values that are set when you create a logon ID. The UID string should not be confused with the OMVS UID value. It is the same name and a very, very different thing. And the other point of reference I would like to make on UID strings is beware of using an asterisk when creating UID strings. They are allowed, however, in the UID string, it is a literal value. But when you put that UID string onto a dataset or recess rule, it becomes a wildcard. So it may not have the effect that you want it to have when protecting. Privileges for users. RACF has, there are others, these are the main ones. System Special. System Special allows a user to administrate any profile on the system and update the global setter op settings minus the auditing ones, as we discussed earlier. It doesn't actually grant very much access. People think System Special, if you've got System Special, you've got access to the whole system. This is not strictly true, but you do have the ability to give yourself access to the whole system if you should require. But what System Special will give you is the access to update or basically access any unprotected data set on the system. Operations does give you a lot of access. It allows the user to access any data with a maximum of alter access unless they are restricted on that dataset profile access control list. Auditor, this allows a user to update the audit global settings, setter op settings, and grant users UAudit, which is to log everything that that user does. If you have a user's ID that you wish to know everything it does for, either it's a system ID or it's an ID that you are monitoring for legal reasons, then you set UAudit on that ID, and only auditor privilege will allow you to do that. The RO audit privilege was brought in, I would say recently, but it's quite a while ago now, to grant System Special users read access to the audit settings. So it's given along with System Special generally. You can give it without System Special, but the people you give it to probably wouldn't know what to do, because I don't think they can issue the setter ops command without System Special. Privileged and trusted apply only to starter tasks. Trusted is for starter tasks where it bypasses all security but will log access, and privileged will bypass all security but will cut no logs. And protected, last one on there for RACF is the user ID cannot log on with a password. So your started tasks would be set as protected because they do not require a password to log on or to start, basically. On ACF2, security, it's the equivalent of System Special, but with added jazz. It allows you to access all data sets and resources on the system and administer the system. So that is a powerful privilege. Non-cancel is technically this. Excuse me, I just missed out something. You can restrict your security users by giving them rule validation and resource validation privileges, which will restrict them to only being able to access rules that they are on the access list for. So it is scopable. Non-cancel isn't scopable without the use of an exit, really, and that will give access to all rules and all resources on the system. It's sort of the equivalent of trusted because it is logged, but it's still quite powerful. And you can also, whereas privileged and trusted can only be added to started tasks on RACF, non-cancel can be added to any user ID. So I would hope on your ACF2 systems, you have very few, if not none, non-cancel IDs. Audit, I forgot audit. Audit is the same as read-only audit on RACF, so it allows you to read audit settings. And read all is pretty much basically exactly what it says. It gives you the access to read all the data sets on the system. A couple more for ACF2. STC is required to allow a started task to run, and it will automatically set the ID up with no password. And by default, started tasks on ACF2 run under a logon ID, which is the same as the started task name. It's similar to the ST data segment on RACF, coupled with protected setting for the ID, but it's like a one-stop shop. And restrict is similar to protect on RACF in so much that it will mean the ID cannot log on with a password. You do not need to give an STC on a ACF2 the restrict attribute unless they are going to submit jobs. Yeah, then you would need to give it to them. Otherwise, if it's just a basic STC that's running in the background, it doesn't need restrict because the STC privilege already means it cannot log on without an access and a password. I apologize. Just before we get to the end, I'd just like to say a special thanks to Kira O'Connor, fellow BMC employee and my ACF2 go-to guru. She has provided me so much knowledge on ACF2 and inspired many parts of this presentation from one of her previous ACF2 presentations. And also a quick mention to Carla, Julie and Reg, whose old RACF ACF2 presentations I have used as a baseline for this presentation. So are there any questions? Apologies, it is a very dry subject. So if you're all asleep now, I do apologize. Hopefully the next session will wake you up.
Yeah, so if there's any questions, just raise your hand or enter it in the chat. I think we're all good, Amy. I don't think there's any questions.
Excellent, that's all good. I'm hoping they're not asking questions because they're all asleep and I have at least educated them slightly. There's, as I said earlier, there's so much more to both RACF and ACF2 that you could say a dataset profile does this, and then but there's also this that can change it, and you can start diving down so many rabbit holes when doing these sort of presentations, and they become very, very technical very quickly. At this point, I would normally be saying I'm in the bar later if anyone has any questions, but I'm not. But if you wish to ping me an email, if you do have a question that you don't want to raise your hand for, I will do my best to answer it for you.
But it would be just a couple in the chat.
If not, please submit your session feedback. You can do it online if you can't read the QR code at the bottom there, session 1AL. And apart from that, that's it from me. Have a lovely rest of your day.
Oh, that's great. I mean, I've just got one quick question from Christian. Curtsy, if that's okay.
Yeah.
I'll just unmute him. Right, there we go. Christian, so you've got a question.
Simon, hi. Can you hear me?
Very, very faintly, Christian.
Sorry about that. So IBM has a recommendation to be extremely careful to whom you give special and auditor privileges in the same time, because they have unrestricted access to the system, if I remember correctly.
Yes.
So basically, they're the god of the mainframe, if you want to put it like this. In ACF2, is there this sort of combination like security and read all or something like that, that we should be aware of?
the one that you would definitely want to be aware of, where are we?
Yeah,
Yeah.
yeah.
Security is scopable. So if you use the rule validation and the resource validation restrictions on security, that will restrict them down to only being allowed to access resources that they are on the access list to. You can also scope them further by using the scope facility, which is a bit more complicated. So I don't really want to go fully into it here, but you can restrict it down. But the one that you really want to be very careful with is non-cancel, because non-cancel is not scopable and restrictable. So if someone has access to non-cancel, they can access any resource on the system.
So basically, it's a sort of special.
Well, it's sort of special and operations and auditor all rolled into one. So whilst the non-cancel people can't update the GSO settings, they can access any data set or resource. So, I mean, it was designed by ACF2 as a very much a get out of jail card. So you would have possibly one ID with non-cancel that you would only sort of invoke if your system refused to come up in a normal manner. And you could then at least use that ID to bring your system up and see why it's not working without having any sort of ACF2 interference.
Okay, I see. So I'm thinking of a bad actor perspective here. So I mean, let's say you have an insider who's having special and auditor under RACF, so basically they can access whatever they want on the mainframe.
Well, they can't access whatever they want. They can give themselves access. If you've got,
Yeah, exactly.
yeah, but you can restrict that using audit settings so that you would know that they've done that. It's traceable, and if you have any security add-ons, for example, Z-Secure or Vanguard, then you could set rules in place to stop them being able to give themselves access to resources. But you would, I completely agree. You would definitely need to restrict who has special and who has auditor. The same people can have access. So you can give people special and auditor, because the auditor one basically only gives you access to put you audit on and update the audit settings. But you'd probably want your auditors to do that, because you wouldn't want a single point being able to change the audit settings. If you see what I mean, you wouldn't want a special user to go, I want to change these audit settings. But you would restrict it to your trusted users. And I mean, most shops only have 5, 6 system special IDs. If that, there are some that I know there are some out there that run with sort of one, and that's your emergency break glass ID. And any real users are not running with special operations.
Okay, thank you very much.
No problem. Thank you.
Brilliant. Thanks, Eamon. Just one more question as well. I'm going to ask on behalf of Kira, which I'm interested in as well. Which do you prefer out of the two?
Which do I prefer? If I was going to put my hand in the air, I would have to say RACF, simply because I've worked on it more and I know it's better. ACF2 does have some very good features about it, but I mean, I do think RACF could learn from the access levels, into fact that if you only want to give a ID allocate, i.e. update access to a data set, because the job it writes has to update the data set, but it doesn't need to read the data that's in there, you could do that. Whereas on RACF, if you give it update access, it can automatically read the data as well.
Yeah,
I think that's really good. So if I was to say, I would prefer RACF because I know it better and I can sit down and get running on a RACF system a lot quicker. If you were to ask me which one is best, I would say they both do the same job. And if properly configured, they can both secure your system equally as well.
Yeah. Okay. Yeah. Cool. I think RACF just a bit more. I think it's on most systems, isn't it? So it's a bit more getting you easy to use.
I mean, to be fair, it is more straightforward. So, I mean, ACF2 is a little bit more fiddly. So to update a resource or a dataset rule, you have to decompile it. You then update it. You go recompile it, and it says you can't recompile this because it's bigger than 4K. You then have to go and pull the rule apart to make it smaller. Have a next key to make sure you're still protecting everything you want. You then have to make sure your next key works properly, and it's things like that. It can be a lot fiddlier. I mean, there's a lot it could do to make it easier for the security people, but the bottom line is it still protects your data, and it protects it quite well. The fact that it is quite fiddly means potentially it's harder to hack because people know the back doors in RACF and they don't know the back doors so much in ACF2. However, if you can get access to a non-cancel or a security ID that's unscoped, you've pretty much given away your entire system. So
yeah,
it swings and roundabouts, to be perfectly honest, Harvey.
Yeah, no, that's fair enough. I've got another question from Jamie Peace.
All my ex-colleagues are just out to get me today. Andrew Cameron Heffer will probably be popping up with a difficult question next.
Do you ever need to reorg the ACF2 databases?
That I couldn't tell you. I've never done it. Well, actually, I have done it once. So yes, you can reorg them. I don't think they need. I mean, they because they work differently. I don't think they reorg in the same way. You'd probably need to speak to Kira from a sort of system programmers, because I've only ever came in as a security person. I've never been a system programmer on ACF2. So I don't know off the top of my head. I can find out for Jamie, and by finding out, I mean I'll ask Kira.
Yeah, no, that's fair enough. Kira's just mentioned in the chat, they'll benefit from periodic reorg. So yeah, kind of here and there really. Yeah, so if there are any more questions, yeah, just feel free to email Eamon or.
Yeah, no problem.
Brilliant. Well, thank you very much, Eamon.
No problem, Harvey. Thank you very much. I believe there is a last slide that I'm allowed to mention briefly, but I'm not going to plug it. So,
yeah, be sure to leave feedback, everybody. And yeah, well, thank you very much, Eamon.
No problem, Harvey. Thank you very much. Everyone, have a great day.
Have a great day, everyone.